Let's take a look at 17.3, rotations. This is the third and final type of transformation that's a rigid motion. Remember that a rigid motion is that when you do a transformation, it preserves both the side length measure and also angle measures. Those stay the same. So pretty much from the pre-image to the image, it stays the same. If you're not sure what that means, please go back to 16.3, and then also 17.1 and 17.2. I mentioned those as well. So in this lesson, we're going to be doing rotations, and rotations involve knowing how to measure angles. So I have this protractor here that's going to help me explain some of the things I'll be talking about and to use as a visual for you. But if you want to see me do this in person, please don't hesitate to come and ask me, and I can show you using the protractors that we have in class. On page 858 are some important definitions. So first of all, a rotation involves going around what we call a center of rotation. And depending on how far around it goes, that's going to be our angle of rotation. So keep in mind that if we were to go all the way around, that is 360 degrees. The direction I go is also important. So the way that I drew my arrow, my circle, is I went in the clockwise direction. The only other way you can go was counterclockwise. But it is important which way you're going to know where your new image is going to be. The example I'm going to go through next follows these steps that you see on this page and on the next page. So where you see it says step 1, and the next page, here you see it says step 2 up at the top and step 3, and then it repeats it again for step B. So I highly recommend you read through those steps. You try to understand those steps, because I'm going to do the exact same thing, but I'll be doing it on the your turns. Your turn on page 860. I'm going to try number 4 here. We want to do a counterclockwise rotation of 40 degrees around point P. The direction just says draw the image of the triangle after the given rotation. So what we want to do is, first, before I actually start doing our rotation, just want to identify a few things. Point P, we call that our center of rotation. Remember that from our definitions. 40 degrees, that's our angle of rotation. And finally, counterclockwise, that's going to be our direction of our rotation. So what we want to do, first step, is to draw a line from the center to any of your 3 points. You're just going to repeat this for the other 2 points, so you just pick one to start with. So I'll pick point L. So I'll draw a line from there. And the next thing we need to do is measure that 40-degree angle. So I'm going to take my protractor here, and this isn't going to be perfect just because it's a little harder to do this digitally, but I'm going to set this protractor here, and I want to do a 40-degree angle. So based on this, it looks like my 40 degrees is about here. Okay? And then from there, I need to figure out how long P to L is. So how long is PL? And we would need a ruler for that. When I measure it, I'm actually not going to be using a ruler with any real units. So don't think that this thing is in centimeters or inches. It looks like about 5.2 using my ruler, which means on this protractor here, it's going to be a little challenging, but I want to go about, again, 5.2 inches this way. So you see my ruler is lined up from point P to where that red mark is. right there. Because when I draw this side along with the first side that I drew, that creates a 40-degree angle. That's 40 degrees, and therefore that means we've rotated point L 40 degrees. So let's move this stuff out of the way. Let's move the protractor out of the way, actually. And I know that my point is going to be about there. And we would call that point L prime. So now I can go ahead and draw my line from P to L prime. I'm going to actually suggest that you erase these lines so that you can do the next one. But there we go. From L to P to L prime, that's 40 degrees. Remember that. They're both the same distance to the center of rotation, and we're just going to copy the same steps. We're going to repeat the steps for both K and J. So I'm just going to do one more just for the sake of time and so that we can move on and do other examples. If I do point K, so let me erase the two lines that I have there. There we go. I have my line from P to K. I'll set my protractor right there. And as you can see, the angle 40 degrees. There it is. I've already marked it. My mark is staying with my protractor, so that's where I want it. So if I draw this side right here, right, I want to measure how long this is. So take my ruler, and that side is about 4.5, maybe a little bit longer than 4.5. Okay, try to be as precise as possible. And if I go this way, and then I'm also going to be moving my protractor out of the way. So there we go. I think I have it just about lined up. So I'm going to go about 4.5, or again, a little bit longer than 4.5. So I end up right about here, and that's my K prime. So let's move this out of the way. And there we go. We have both K, L, and J. The pre-image, remember, is right here, and we so far have rotated 2 of the points. Now when you do the other point, it should be somewhere in the range of about here, so that we have our triangle. Now I'm going to show you a cool feature of this app here, which shows you the rotation and how it's going to line up with L and J. I'm sorry, L prime and K prime that I have up at the top. You see I've outlined the triangle in blue, and now I'm going to show you this thing being rotated. And just cross my fingers here that this works. So I'm going to force this thing to actually rotate. And there you see it. It is moving. And if I were to pause it, it's up right there. So this isn't completely accurate. It could have been the way I set my rotation. But you see right there, my L prime point is a little bit off. I probably measured out a little bit too far. If I went a little bit closer to point P, right there, let's see if it'll allow me to move it. Not quite yet. I'll fix it here in a moment. But you can see that rotating it like that is almost like using the transparency, if you remember me using that in class. And also, let me mention that point J, the image of J, which is J prime, should be, again, somewhere up here. If this is accurate, then it should be actually right there with that, where that point is. Okay, I'm not going to do number 5. Definitely practice that. You have a problem in your homework assignment where you're doing this. All right, this one here is a little bit harder to show on video, so come in and see me if you have a question on that. Down below this example, you're going to see some more information on probably what you learned last year with rotations, which is rotating it just with the 90 degrees and adding 90 degrees to that. So you'll see 90-degree rotation, 180, 270, and then 360 isn't that interesting because we get the exact same thing. We get our pre-image back again. So this is something I do need you to understand, but we're adding the fact that I could ask you for other angle measures. One important thing to note here is that when no direction is specified, that means you're going to be going counterclockwise. Okay, so if all I say is go 90 degrees and that's it, you're assuming that the direction is counterclockwise. And counterclockwise compared to clockwise can give you the same result. All you have to do is subtract 360 minus the angle if you're going the other way. So what I mean by that is 90 degrees counterclockwise, subtract 90 from 360, and that means that other angle measure will be clockwise. So let me actually do that math for you. 90 subtracted from 360 would be 270. So 90 degrees counterclockwise is the same, will give you the same result as 270 degrees clockwise. So that means it's going to give us the same image, it's going to give us the same coordinate rule there, and you can think about these other two and how that would affect it as well. At the top of page 862 are a couple your turns practicing these 90, 180, and 270 degrees. I'll show you a couple ways. In class, I do use the transparency to help you visualize it a little bit better. I'm going to actually rotate this page, the whole page, and try to explain it to you that way. And the other way is also using a rule. So if I'm going to use a rule, the rule for going 90 degrees, and remember this means 90 degrees counterclockwise. The rule is x comma y goes to negative y comma x. So let's take a look at how we use this rule. So x and then y becomes negative y, then x. So these two have switched places, and then whatever y is, it changes the sign. That's what the negative means. So if y is 1, then negative y is negative 1. If y is negative 3, then this would be positive 3. So all we're doing is we're changing it. Okay, so if we can write down the coordinates for these, point P is the point 2, 1. Point Q is the point 4, 1. And point R is 4, negative 3. Okay. So to get the image points, remember we're going to flip 2 and 1. So the 1 will come first and then the 2. And then remember we're changing the y. So we're going to change that to a negative 1. So you can actually do that first. Make that a negative and then flip them. So that would make that a negative 1 and then a 2. This one would be a negative 1 and then a 4. This one would be the negative 3 becomes positive 3 and then the 4. So if we were to plot those points, negative 1 comma 2, negative 1 comma 4, and 3 comma 4. This is our image. Please make sure you are labeling your image with P prime, Q prime, and R prime, or whatever letters they are. It's very, very important so we know which point goes to, of course, which point in the pre-image goes to which point in the image. So here's another way. Let me erase what I just drew here, and then I'm going to rotate the whole thing for us to take a look at. So in order to do it the second method, You notice that this is our y-axis and the x-axis, right? Here is quadrant 1, here's quadrant 2, quadrant 3, and quadrant 4. I'm going to actually rotate the whole page and pretend that that's our new image. So let's do that. I'm going to rotate it 90 degrees this way. Now I want you to pretend as if this is our new y-axis, that's our new x-axis. Here is the quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, so I'm going to be rotating it here several times, but you see that to get R, I have to go right 3, up 4. So when I go back, for R, I go right 3, up 4, and then I mark that point. Then I go back. Go here, oops. Okay, to get to Q, I'm going to go left 1 and up 4. So let's turn it back. Left 1, left 1, up 4. Okay, and you kind of get the idea. That one was R prime and that was Q prime. And I can do the exact same thing for P. Go back like this, and you see that it is left 1, up 2. So then I go back, and then I'm going to go left 1, up 2. So that's my P prime. And there I have the same exact points. I didn't have to apply a rule or anything, just rotating the whole paper. Okay, because I have another example for us to do here, I am not going to go through this example on the right, number 8, but it is a good one to try, and you can check with me should you have any questions. Now we're going to be looking at how do we find the angle of rotation. So on this last your turn, we have the pre-image and the image, and we need to find the angle of rotation. Here I have my handy dandy protractor. So you just pick one of your points and its image as well. We have 4 to choose from. So K, N, M, L doesn't really matter which one because we'll get the same answer. If you don't believe me, you can go and try it out. So I'm going to draw this. I just freehanded it, as you can tell, but use a straight edge when you're doing that. If I picked point N, that means I want to pick N prime, and I'm going to draw that side. That wasn't very straight, so I'm going to try that again. There we go. It's a little better. And I want to measure that angle. So I'm going to take my protractor like so and make it a little bit smaller since I can't see the whole thing here. And looks like I do get about 70 degrees. So here is my line. I didn't draw it very straight, so I try to line it up as best I could. So it goes to N prime. And this here going to point N, it looks like it's about 70 right there. Remember that's 0. So that'll be 10, 20, 30, 40, 50, 60, 70. And that happens to be my angle of rotation. So 70 degrees here. It's also important to identify which one is your pre-image and your image. So just know that one's the pre-image. This one is the image because of the way the points are labeled. With the N prime, K prime, M prime, that means it's already gone through a transformation. So that's our image. So that means it went this way, right? Which way is that? That would be 70 degrees clockwise. And based on what we went over in the last page, we could go this other way, counterclockwise. Counterclockwise. But I would have to subtract 70 from 360. So that happens to be 290 degrees. So it's okay if you put either answer or both answers. They both work.